Hi, so this 2 marks question is from GATE 2015 set 2. Let me read out the statement, then we are going to solve it. Consider a typical disk that rotates at 15,000 rotations per minute, that is RPM, and has a transfer rate of 50 multiplied by 10 raised to the power 6 bytes per second. If the average seek time of the disk is twice the average rotational delay, and the controller's transfer time is 10 times the disk transfer time. The average time in milliseconds to read or write a 512 byte sector of the disk is. Okay, so you can see we are required to find out average time to access one sector. One sector is given as 512 bytes. Now they are saying that transfer rate is 50 multiplied by 10 raised to the power 6 bytes per second. Let's find out how much time will be required by the disk to transfer this much data. So 50 into 10 raised to the power 6 bytes take 1 second. Then you can see 512 bytes will take 1 upon 50 multiplied by 10 raised to the power 6 times 512, and the unit is seconds. So let's calculate it. This will be 512 divided by 50. It is 10.24. Divided by 10 raised to the power 6 seconds. Let's convert it into milliseconds because the answer is required in milliseconds only. It's going to be 0.01024 milliseconds. Okay. So this much time is required for actual data transfer. Let's write it. I'm erasing this. Data transfer requires this much time, 0.01024 millisecond. Then they're saying controller transfer time will be 10 times this disk transfer time. Let's also find what will be the controller transfer time. So this will be 10 times this delay, which comes out to be 0.1024 milliseconds. Okay. Now let's talk about the seek delay and rotational delay. They are saying average seek delay or average seek time is twice the average rotational delay. We can certainly find the rotational delay or average rotational delay because we are given the speed of the disk. So speed of the disk is given as 15,000 rotations in 1 minute. Okay. 15,000 RPM. Now 15,000 rotations per minute means 15,000 rotations in 60 seconds. Okay. That means one rotation is going to take 60 upon 15,000 seconds. So this is 6 upon 1500 seconds. This will be 0.4 divided by 100 second. To convert it into millisecond, you'll see this comes out to be 4 millisecond. Okay. because you can multiply the numerator and denominator both by 10. That will be 40 upon 1000, which is 4 millisecond. Okay. That means one rotation requires 4 milliseconds. Now what will be the average rotational delay? Okay, so now you can see we are required to find out T average, that is average rotational delay. Average rotational delay is the delay required for half rotation. Okay, so half rotation will require 2 milliseconds because a full rotation needs 4 milliseconds. Why is this average rotational delay equal to the delay for half rotation? Because at times you might not require any rotational delay, and at times you might require a full rotation. So the average case will be half rotation. Okay. Then average seek time is twice of average rotational delay. That means this one is rotational delay. Average seek time will be twice of 2 milliseconds, that is 4 milliseconds. Let's write both of these. Average rotational delays Okay, so I have noted down these values. The rotational delay that we just calculated was 2 milliseconds. Average seek time is twice of this delay. Okay. Now you know that formula of average delay for data transfer. This will be So you already know this formula, that average delay for data transfer will be average seek time plus rotational delay plus the time required for actually transferring the data. Now in this question, they have also given this controller transfer time. You know the structure of hard disk. There's this hardware called a disk controller. Its delay will be 0.1. Okay, this is given in the question. Now let's add this also. That means plus the controller delay. So your answer will be 4 plus 2, that is 6, plus these two values. That comes out to be 6.11 to 6. These many milliseconds will be required to transfer 512 bytes or one sector. Okay. So your answer is these many milliseconds.